I'm Stewart Christie. I'm a community manager at Intel. I'm currently doing the Internet of Things community. It's a new community we started beginning of the year. My colleague Daniel Holmand was supposed to be presenting this class, and he wrote the slides. So if you like it, I'll take the credit, and if you don't, we can blame Daniel for all the stuff. So some of the slides I'm familiar with. I've gone through it a couple of times, but it's Daniel's talk. He's the person that does the DIY science pieces there. So I'll answer questions as I can, but no, Daniel's obviously going to be the person there. We'll be putting this up on SlideShare, so if people want links, and we'll put it up on the Intel blog as well once we remove the Intel confidential bits and pieces from the bottom of the slides. So Daniel's got a few quotes in this one, and I like this one as well. The scientific process is something that Daniel likes to follow, and but this person here, Michael Nielsen, thinks that it's going to change. How discoveries are made are going to change a lot faster in the next 20 years than they have in the past 300 years.
When was that written?
That was 2011. Yeah, 2011. Yeah, so yeah. So we're 3 years in. Yeah. So, and then there's another quote. Does anybody know what this guy said that made him infamous? Everything that can be invented has been invented. and that was like, no, obviously 1900 or something that he was down there. A caveat to that, right? It's not strictly true, but if you go out and look, if you've got an idea and you go out and look for it on the internet these days, somebody else has probably invented it already, or is building one of them, or can help you build something that you're interested in. And that's basically the topic of this, the theme of this talk, is that it's highly unlikely that you're the first person to think of that idea. There's probably a community out there that can help you build that idea if you're willing to. Now, if you want to, you can go and live in a cave and develop it and try and build it. And you may invent something that's unique or a modification or something. But for citizen science, it's a bunch of citizens that we're pulling together. Now this list here, right? Why are the bees disappearing, right? Can we trace our origins through our own DNA? Can you map the mind, right? Quantum computing, weather predictions, no, the tracking environment pieces, city pollution, real time, how do galaxies form, right? The speech of whales. Can we find a vaccine for Ebola? Are there M-class Earth-like planets out there? The thing that these have in common is that there are citizen projects out there already looking for these things. So if you were interested in something like this and you want to get involved, right, there are already these projects out there. No, we'll show you today a list of other ones. Now these DIY scientists have been around for a while. They were obviously around before corporations decided that they would do the science and the research. I've got to read the notes on some of these people. Most of them I recognize, but Maria Sibylla Marian, I'm not too sure, so hold on. All right. She was one of the first scientific illustrators. So that was her piece in there. So butterflies, moths, and those sort of pieces. So actual, I wouldn't call them technical illustrations, but illustrating animals and devices in a scientific way. This is how we generally think of scientists these days, right? That's typical, at least in a corporate environment. Even Intel Labs, right? We call it Intel Labs. There's no lab, right? But it's that department, they literally call themselves Intel Labs or Intel Research. And no, they wear white coats at Halloween, right? That's the only time they do it. They got these things around there. But citizen science really is something I would say it's fairly new, or at least it's got a new term. The term's come up for it, and it's really non-professional scientists, amateurs, who are developing and working on some of these projects. And no, the participation is varied, right? You can work from home. You can connect with people in different countries, or you can gather at makerspaces and do projects like that going together. And it can be, it can range from actual, doing real, hands-on work, going out into the field, or just the discovering the new way of solving the problems. So the thought process. So the thought process one is one that we'll probably start off with. And these are some of the ways that citizen science is working, right? We're going through a bunch of different things. So obviously the internet, that's a given. But big data, right? You can analyze a lot more things these days because of the huge databases out there. The Internet of Things allows us to connect multiple devices, thousands of devices, into a database and effectively get some of the big data. And then these, the fact that everybody in here has probably got a cell phone, right? And we can connect to it and read the temperature, or read your position, or figure out if there's an earthquake in this room, or that everybody's rushing out this room because there's something else going wrong. Those are the sort of things that people are starting to do with personalized technology. Effectively crowd detection, right? I've seen some articles where they're doing, they can detect a riot, right? Because there's a mass of phones rushing down a street, and presumably they've got people with them, and they're determining, okay, that's where they should send the police or the riot gears or the rescue people, because there's something going wrong there. And then the maker movement is it's wild and woolly. There's a lot of stuff going on there. And that ranges from electronics, which I'm familiar with, to biology. There's a fairly well-established place in Oakland that's doing DIY biology, and it's fairly advanced stuff. It's certainly beyond any of my high school biology pieces. So, changing different ways of solving problems, right, or different ways of thinking about a problem. This was one of an example of one of those things, and this professor out there, he's often called he won the Fields Medal. It's colloquially known as the Nobel Prize of Mathematics, right? He's very he's quite an active blogger, and this is one of the proposals that he put out there, was to try and solve this problem. And rather than work with his colleagues at the university, he put it out there for for individuals and other citizens to work within there. So within about 37 days, just over a month, there were about 800 mathematical comments with 170,000 words through that this thing proposed there. So it's a networked science project that this one put forward. This one here is big data, all right? And it's done as a game. It's gamified. So at Galaxy Zoo, these people are are looking at galaxy research, and basically you can play and classify these things. This one's obviously fairly easy to figure out, right? It's a spiral galaxy, right? And regular algorithms can detect this. It's not a problem. But no, there are myriad different types of galaxies, and having them classified is something that the machines just aren't up to yet. So they're having people go out there and classify these galaxies and then move on from there. This one's the DNA project, all right? To get involved with this one, you take a swab and you send it in, and you tell people, you say where you are right now, but then they'll track all the stuff, and they'll figure out where your relatives came from, and you get the information back from them. So it's, no, this one shows, you can see the map here, where these people in Spain migrated from and to. And so you can join this one fairly easily, basically by sending in your DNA, all right? And it's National Geographic that's running this one, so I find this one particularly interesting. This one is looking for M-class planets. I would have never known what an M-class planet was if I hadn't been for Star Trek. Everybody now knows that's the Earth-type planets. At least you should do. But basically, to detect the planets, what they've got are observations, and they can detect the periodic wobble in a star, or a gravimetric change as something orbits around about these pieces, and they've got all the information up there, and you can join in and start looking for these M-class planets in the data that's coming from this project as well. So this one's exoplanet, if you're interested in that one there. And then this one here is, I'm really not sure about this one, right? A game to map the brain, right? I don't know, my dad's not got Alzheimer's yet, but it's maybe one of these things that I'm going to need coming along. I say I really don't have much more information about this one. This one here, this is a page of different projects, right? So this is a great place, a resource, if you're interested in joining some of these projects, right? The current projects are there, right? But they've got plenty more on the way. So pick a project and join in, or just have a look at it, right? It's one account, and you can contribute to it. And as Daniel says, the Reddit AMA is great reading. It's a very easy to get in. It's very it's none too technical, and they're quite friendly. Put it that way. That's the nice one I like about that. And then Wikipedia. No, it's got a list of citizen science projects, right? There's a large set of those there already. So it's becoming popular enough that you can find that Wikipedia themselves are pulling in stuff like that. The Internet of Things and some of the Maker projects, we'll skip through those because most people will probably know what those are. But the Internet of Things is where the devices themselves are spitting out the data. And then the Maker movement, as I say, it's so varied, right? It's very difficult to classify. If anybody's been to some of these, the Maker pieces in San Mateo, yes, it's science. There's totally different types of science. It's it ranges from beekeeping to, as you say there, cardboard boxes with people inside them. So the Maker movement is another place to find a lot of these bits and pieces, and it's especially popular for children to get involved with that. So we're working on citizen science projects with our IoT devices. There's a large number of project sensors, devices that people are picking up using our stuff there, and the kits that we've got in our booth are being used for that. We've got a a complete health kit from a company called Libelium, and it's got medically approved sensors that you can use for blood pressure and oxygenation and all of those sort of pieces. So you can actually deploy them out in the field, right, and not get, well, you might still have problems with the medical sort of things, but the devices themselves at least are approved for people to use in their home. The debate over whether it's a medical device and a health device is something I'm going to steer clear of, because that's no, it's one of these. It's something I want to steer clear of. Definitely one of those strange topics. So we're doing a lot of stuff with Arduino. It's an Arduino-based board that we've got in our booth. Some of you may have seen it yesterday. We had a piece of citizen science last night in the room across the way where we were building beer detectors, and one of our winners is here today. I think yours was the warm. Yeah, you modified it and made it warm beer detector. Yeah, so yeah. We have a series of road shows which are running. The next one's this weekend in New York City. So unless somebody's here from New York City, it's kind of difficult to go. This is one of the boards that we're using for that. Again, it's an Arduino compatible board. It's got an Intel Edison on it. It's a dual core Atom. It's a PC on a module. It's got a gig of flash, a 4 gig of RAM, a Linux operating system, and you can plug in the modules, the shields, and everything, and build yourself a fairly decent project with some of these. And we've got an example of one of the things that Daniel's built later with this. We've got a Galileo board. The difference with this one and the previous one is Wi-Fi and Bluetooth. This one's wired. It's got Ethernet. It's got a PCI Express slot on the back, so you can plug in a Wi-Fi card if you want and get some connection in the field, or even plug in a 3G device and put it way out in the field and get cellular connection on it. Again, it's Arduino compatible, so you can see the 6 analog inputs and the 20 digital I/O pins. So you can plug in regular shields into this one. Again, as I say, you can plug in the medical shield into this one, and it's fully supported with all the software and everything out there.
So this must plug into the PC?
No, it's standalone. Yeah, I mean, for development, obviously, you plug it into PC, but no, that's a PC. Yeah, that's if we go back, it's a complete motherboard, Linux operating system, the whole deal there. Yeah, it's fairly small, but basically, yeah, it's a PC. No screen, there's no graphics output, but other than that, it's no. It's effectively an embedded PC. Think of it that way. This is one of the sensor kits that we support with our libraries, and you see there this type of sensors. At this stage, it's a learning kit. There's about 300 sensors. If you go to the Seed Studio, the Grove company that makes this, Seed Studio is the company that makes this. This is Grove, their product line, and we've got in our kit mostly analog and digital sensors. We've got an I2C LCD. Most of the complicated sensors, no, it's difficult to get 9 degrees of freedom from an accelerometer out through an analog port. So those are connected via I2C. So a lot of the sensors are smart. Some of the motor controllers that we're using, they've actually got an Arduino on them that does the I2C and then a driver on there. So they're Arduino-based boards that we plug into this Arduino-based board as well to do that. So there's a range of, say, different sensors for different things. And this one, we've got the temperature sensor, light sensors. So those are, if you want to get started with a weather station, something like that might work for this one. This is what's inside the kit, right? Power supplies, cables, all the bits to get you going. And then when we're doing these road shows, these are the devices that we tend to take along, right? The air quality sensors, compasses, gyros, accelerations. Those are the ones that I talk about that are I2C connections, right? They're more than just one analog channel, for example. But there's a range of those things, and the devices are $3, $4, $5. They can range up to $20 or so. We're paired up with Instructables to have people post all their projects on there. So there's actually an IoT hub on Instructables. And if you're doing any of the science, you're using any of our boards, we'd love to get the stuff up there on Instructables as part of the place to get people to find out how to build it. One of the things about Instructables is you don't really show the end product, you show how you built it. Right, so we want other people to figure out how did you build this, right? If you look at the Intel logo for the maker, it's what will you make, right? I'm interested in what you make, but really I want to know how did you make it, and that's what we're using Instructables for, so that we can find out how you built it, so that other people can copy it, or duplicate it, or make it better, and go on from there. So some sensors and projects. Simple reading a potentiometer, right? This is a C++ example. We've got a bunch of libraries for reading the potentiometer. We've got a bunch of all the software, all the sensors are available. I'm going to skip through them and go right to a slightly more complicated one. Now that this is up on the big screen, you can see that the photograph has been reversed. But this is a temperature and a humidity sensor. So this is a slightly more complicated one. It's got a couple of signals coming off of it. You can read just the temperature of it, but this is an example of one of these hybrid sensors out there. And as I say, there's a range of about 300 or 500 sensors. You can plug pretty much anything into one of these boards. Adafruit, SparkFun, a bunch of the regular companies sell these devices. As I say, we were saying, what will you make, right? That's the slogan that Intel's sort of promoting. Personally, as I say, I'm interested in what you make, but I really want to know how did you make it, right? So that I can make one the same, right? So that's what we're using the Instructables site for that. So this is an example of some of the things that you can do. Daniel, as you can check out here, is up in Oregon. So now Portland is where he resides, and these are personal weather stations that people have connected to this weather underground. Right now, you can build one using enough of the sensors in our box. Right, there's a temperature sensor, there's a light sensor. You can develop it, and these are all the people there. And now they've got. You can see some of them there have got the wind direction. Right, there's a little arrow with the wind direction, so obviously got a bit more than some of the others. The rest of them are reading the temperature. It looks like it's about in the high 50s in Portland when Daniel took this screenshot. So you can build your own one and start doing this. So as I say, it's a microclimate piece. I don't know how many, probably 50 or so. Yeah, it's a fair number just in that section there within Portland. So build your own weather station, right? These are the sensors that they've got there. They've even got now a way of making a rain gauge. We could make the rain gauge out of our beer detector that we were working with yesterday. It measures the level of water in a glass. The rain gauge tipping bucket that's mentioned at the bottom is a fun one that would work up in Daniel's area, but I live in Arizona, and we don't get enough rain for something like this to work. But what this does is it fills up the bucket. Once it's there, there's enough water, it tips over to one side, and then it fills up the other one. In Arizona, before you fill it up, it would dry out, and we'd end up with mosquitoes in it. So something like this doesn't work terribly well in Arizona. Unless, of course, we get the storms, in which case the bucket would fill up, right? We tend to get large storms coming through. But this one, rather than measuring a little thing, it's got a little, it measures a button, like click, 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 every time this thing flips back and forth. So, and you can see from this one, right, it's a home-built sensor as well. So building your own sensors is another set of projects that people are doing. So measuring solar energy. Daniel built a solar collector. I'll be polite and say he over-engineered it somewhat. You don't need such a big battery to run a Galileo, but he didn't know that when he first started out there. So he's got this really, really large solar cell and a really, really large battery. But the little sensors are available that will scale these things down. He's bought himself a solar cell controller, but then he's got a set of servos that point to the brightest point in the sky. It's a solar tracker, and it's fairly effective. No, he's got it running in Portland. It rains a fair bit, so he's got an ammo can as the case for putting the piece in there. He's blown it up more than once. He's melted the wires because his battery is so big, and if he gets it wrong, but he's got that system running. He's got the piece that he designed, right, other than bought, was this light sensor. So he's 3D printed effectively across, and he's got 4 of these light sensors on there. And as it's shining towards the sun, there'll be a shadow cast on the sensor that's the darkest, and he can use that to figure it out, and that then moves the thing. And he's even got some math in there that the cosine of the angle of incidence and everything. So he's got that thing working. If you can go onto the site, we've got a tracking thing up on the cloud, so the information is being tracked up to the cloud. We're trying to calibrate it to figure out what's the wattage per square mile in Portland with one of these systems right now. He's got the weather piece of it running. I'm going to say we're running with the cloud to do that. If you come by the booth, we can give you the links and everything, or we'll have it up on the slides. If you're interested in building one of these or just tracking the weather in Portland. I've lost my mouse. There we go. So one more thing that you can build with our dev kit already built in there is the light pollution detector. As I say, we used it for something not quite so sort of citizen-like. We used it last night to detect the level of beer in a beer glass, which I think is just almost as important as cities at night. But this is another project where you can detect light pollution. I live not far from Tucson. I can drive down to Tucson, and it's one of those cities that's got a night protection thing, and the stars there are definitely a lot brighter than they are up in Phoenix. So if you're interested in this sort of stuff, this is another site that we can recommend. I think that's pretty much it. We're moving over to question time now. Let's see if we can go this one last slide. So if you come by the booth, we've got a passport stamp. You can go around. You can win yourself one of these kits. The other thing that I'd like to do is see if there's anybody interested in any projects that they want to advertise. We've got a microphone there. Is anybody here doing citizen science? That's what we want to know, right? And it's all quiet, right? So why are you here at the class, right?
I'm interested to a sensor to be able to detect rough edge
So he's looking for a sensor to detect blood pressure. Yes, so there's a blood pressure sensor, the cuff piece that connects into the Galileo. There's a company called Libelium out of Spain that's building it. It's part of their health kit. So Libelium, Libellium. So yeah, they've got the blood sensor, or the blood pressure cuff. Anybody else doing some citizen science? Any projects going? You want to come up and speak to the microphone?
Just to fill some space for you. I'm building, I build urban farms out in Richmond. We take empty lots and put food production into them. One of the technologies that we're using is aquaponics, which is a closed system of hydroponics, soil-less plant growing, and aquaculture, fish. So it's a closed cycle of basically the fish shitting and feeding the plants, and the plants filtering the water for the fish. It's very efficient, high-density farming. It's a system that needs to be measured for balance of water quality, temperature, acidity, pH, the whole thing. So I've been using Arduino to build out a bunch of, to put in a bunch of sensors that tweet me, publish to the web, the conditions of the aquaponics system.
Okay, so that's up on the web publicly, or is it just a private piece
right now
you're
it's
using
all
yourself?
just stuff that I do myself. But the sticking point is the sensors are expensive. There's no way to reasonably put these systems in on these urban lots because to measure the ammonia levels in the tank, you're looking at a sensor that's a couple of $100, which is prohibitive.
Yeah, yeah. We've got some sensors that we've got from the Seed Studio team that do gas measurement, so they do volatile compounds and things. They're not terribly well calibrated, but you might be able to use one of your expensive ones to calibrate it. And those things are coming in around $15 or so.
Oh, wow.
They take about a day to balance and calibrate. They've got a volatile compound sensor. They've got an alcohol sensor we used last night for our beer detector. There's some slightly more expensive ones, but the maximum price I think is about $50 or so. And those are single one-off prices as well. So there's another project that we're working with. There's an Arizona Makers Club at Intel, and in a similar sort of thing, there's a reptile rescue place in Arizona, and in the summer it's perfectly fine, right? The temperature of the water is great for these 300 crocodiles that they've got swimming around, but in the winter they want to have to heat the water, and they've got a similar sort of issue that they had to have somebody go in every 2 or 3 hours and make sure the heater was on. So we're helping to connect that to the cloud, so at least he gets a tweet or a phone message saying the heater's gone off and come in and do that. So it sounds similar in some ways to the hydroponics.
Yep.
Use the sensors there.
So I look forward to learning more about your stuff.
Yeah.
Thanks.
Anybody else building anything? Any projects that in the citizen science of realm of things? No. So why are you all here in the class? That's maybe the other question, right? You're looking for ideas. Yeah. Yeah. Well, as I say, that's pretty much all we've got at this point. Thanks for coming. We're slowly filling out our instructables piece. Ping me on Twitter if you've got an idea. We got a bunch of boards that we had at our beer detector yesterday. If you can come up with a good idea, we've got some of these slightly used boards and sensor kits, so we will be giving them away. If you come by the booth this afternoon, I'll be in the booth until 5. So come with a good idea, and we'll see if we can get you a board and the sensor kit. Thanks very much.